Okay, so in this video, we're looking at similar triangles, specifically proving when triangles are similar. Now, in the previous video, we talked about what makes something similar, their corresponding angles are the same, and also their corresponding sides have the same ratio. Now, with any shape other than a triangle, you have to prove both of these things if you are wanting to show something is similar. The reason why is think about a rectangle. While all the corners will be 90 degrees, one rectangle could be slightly longer than the other, making the lengths different. And in turn, if we were to think about a rhombus and like a square or something, the lengths could all be the same, but the angles will be different in the shape. So let's take a look at what makes the triangle so special. So, if the pairs of corresponding angles are equal, and we're going to use this term equiangular, that means by default the ratios of corresponding sides are equal and therefore the triangles are similar. And in turn, if the ratio of pairs of corresponding sides are equal, by default that means it is equiangular and therefore the triangles are similar. So triangles, you only have to prove one and then it means the rest is true. So let's take a look at a couple of examples that I have laid out. Okay, so this first one, we are being asked, are the following triangles similar? So I've got these two triangles here and they've got some of the angles. So I need to prove that that the triangle has all the same angles within them. So I need to find out what the missing angles are. So here, I'm going to do 180, take away my other two angles added together, which gives me 180, take away 110. So that is just going to be 70 degrees in there. And then in turn down here, that'll be 180, take away the other two angles added together. So 180, take away 130, which would just be 50 degrees. And as we can see, in each of our corners, they all share a pair. So we've got a 50 and a 50, we've got a 60 and a 60, and we have a 70 and a 70. So what we need to do now is write a statement. So I'd say, since the triangles are equiangular, they are similar. So let's take a look at this next example. So again, finding out what the missing angles are. So 180, take away the other two sides angles added together. So it's going to be 180, take away 145, which will just come out to 35 degrees. And same idea here, 180, take away the other two angles added together. So 180, take away, that would come out to 90. So that's just going to be 90 degrees in there. So in this case, they aren't equiangular because we can only spot one pair. Our only pair is that 25. But nothing else pairs up at all. So we would say, since the triangles are not equiangular, they are not similar. So that's how to do it when we have the angles. Let's take a look at how to do it when we are dealing with the sides. So, got two more sets of questions. The ideas are the same. I want to prove whether or not they are similar. Now, the easiest way to go about these is to match the sizing of your triangles. So, the corresponding sides will go from your largest down to your smallest. So that 18 millimeters is my largest in that triangle, and the 12 here. So that's a pair. My next pair would be the 14.5, and then the 10 is my next largest. And then my smallest, oh, not the 14.5, what am I saying? The 15 and the 10 are my next largest. And that leaves us 14.5 and the 9 as my smallest. So what I would do, I would just choose one of them to be my new, doesn't matter which one I pick. So my new and my old. And so I need to check to see if my scale factor, when I simplify, all comes to the same thing. So remember, my scale factor is my new over old. So matching the pairs, I'm going to start my biggest. So 15 over 10. When that simplifies down to, divide them both by 5, so that'll be 3 over 2. Then my next pair, the next largest, is going to be, oh, I didn't even do the largest. The largest one is the 18 over 12. So 18 over 12, we can divide them both by 6, that comes to 3 over 2. And then my last one, the 9 and the 14.5, so 14.5 over 9. And here, if it's not obvious, if you're allowed to use a calculator, you can always put it in the calculator for it to simplify for you. And in this case, it comes out to 29 over 18. So because of this one scale factor, that means it is not similar because it's not all the same. So I'd write, since the ratios of the corresponding sides are not all equal, it is not similar. Okay, so let's take a look at this last one here. So same idea, I want to match up my pairs. So I always go for largest first. I've got the 28 and the 63. So let's just jump straight into doing our ratios. So 63 over 28, that simplifies down to 63 over 28, 9 over 4. And then my next pair, I've got this 18 here and the 40.5. So 18 over 40.5. And that would come out to I've put it the wrong way around. This is why you should always write out new over old. Right, all right. My bad. I'm going to make that my new one and that my old, because that's what I used in the previous one. Sorry about that. So my new is that lost where I was. I'm on the blue. So new is the 40.5, and there's my 18. So that would just be 9 over 4. And then my last one, the 14 and the 31.5. So 31.5 over 14. Putting that in the calculator comes out to 9 over 4. So in this case, they are all equal. So that means this is going to be similar. So I write that down. Since the ratios of the corresponding sides are all equal, it is similar. So that's how to prove whether or not our triangles are similar. Let me know if you have any questions, and good luck with the work.